Yes, good evening, everyone. Hello, good evening, Tasimobi. Good evening, Favor. Please, are you
Good
there?
evening, good evening, sir. Good evening, sir. Yeah, just go inside.
Yes, good evening. Favor, are you there too? Favor, are you
Good
there?
evening,
Good
sir.
evening. Good evening. Okay. If you can speak, it's dropping message in the group chat. Okay. So, please, right, before we proceed with today's class, I want to ask some few questions, right? And then from there, we'll just take it up. Okay. I think it's been let me say 5 week or 6 week thereabouts, right? And then we started with machine learning. We've done our libraries importation. We've gone through. Please, can you hear me? Hello, hello.
Yes, I can hear you.
Thank you. So we've gone through data inspection, data visualization, right? And then we also treat or remove outlier from the data set, right? And and also we worked on scaling. And last week we used a minimal scaler. So my first question is this, right? Do you have any questions so far? That is one. And two, do you think there's any topic, right? I should uh, I should retake again. That is two. And three. Yeah. Okay. So the first one is, do you have any question? And the second one is, do you have any topic you want me to retake? So I can quickly do that before we start today's class. So please, you can all speak now. Hello, Nasiru.
Yeah, sir. Good evening, sir.
Good evening, sir. Speak to yourself.
Yeah, Mr. Eze, you are welcome. Of a truth, this our class so far has been interesting, and what makes it so beautiful is that one, we have a class recording. Two, we have materials to practicalize on those things. Three, we also have our codes in the sense that if we want to, anywhere we do not understand, listening like me, I always download the class lessons. I have a place I'm storing all of them. So if there's anything you teach on any day, I want to go back or I have forgotten how to do it or what you explained before arriving, I'll just go back and listen to those your voices again. So far the class has been interesting, and I believe that as we go further, it will become more interesting to myself and every one of us as well. Thank you so
Thank
much,
you,
sir.
Mr. Thank you, Mr.
Yes, sir.
Chimubi.
Yes, sir.
Okay. Yes. And okay, before I speak, right? I want either favor. Please, can you speak? Favor to speak. Then after that, gospel will speak, and then the what I mean. Okay,
Good
please
evening,
go on.
sir.
Yeah, go on. Good evening, favor.
Okay, so far I don't have questions except on outliers. I am
Okay,
still
okay.
confused to
Yeah,
detect
clients, right?
outliers data
Okay,
sets. So I think
okay,
that's the
okay.
only place I'm having issue.
All right. Okay. I think that will be fixed. Okay. Yeah. What about gospel? Any questions so far from your end? Hello, Goswin. How you there? Hello. Hello, Goswin.
Hello, good evening, sir. Good evening,
Yeah,
everyone. Good evening, Mr. Sylvanus.
good evening.
Um, I don't have any question actually. I'm all in. I don't have any question. Thank you.
All right. Gochukwu. Good evening, Gochukwu.
Good evening.
Yeah, good evening. Hope you are doing very well today.
Yes, sir. How are you?
Yeah, I'm okay. So, right, I asked them a question. I said, so far, we spent, I think, over 6 weeks or 5 weeks. mhm, And I asked if you have any question, right, or you have any topic you feel I should take again. You get that? Hello? Hello, Gospel. Can you? Sorry, Gospel. Hello, Gochuku. Did you get that? I think it's having bad network.
I can hear you, sir.
No, I mean, Gochuku. Gochuku, can you hear me now?
Probably her network is bad.
It's bad, yes. Okay. So let's proceed. Right? Let's proceed. Let's launch our Anaconda. Now, the reason why I am saying this, right, is it's I want to.
I can
Okay.
hear you, sir.
Yes.
Hello,
Yes.
I can
Please
hear
go on.
you.
Go on.
Hello?
Please, I can hear you, Gochuku. Hello. Okay. So as I was saying, right, I said the main reason why I'm asking this question is I want you guys to fully understand what ML, right, is all about. And then aside from aside this particular training, right, maybe to just pass the exam or to just pass the whole the whole aim of this particular training. Now, my concern is that it will give me, or let me say, to be of a greater joy to me if you fully please hold on, please, Gochuku. You fully understand this ML, right? Because we are going deeper. We are going deeper. Yes, we are in the world of AI. We are in the world of AI, and truth be told, right? Truth be told, um, if you understand ML very well, it will make AI much easier for you guys. You understand? I'm speaking from experience. Yes, to make AI much easier for you. And for now, right, for now, it is not compulsory that you learn how to write the code offhand. You can always refer back to your previous codes. Very sure and very correct. And yeah, and it is acceptable, right? But you should understand the purpose, right, or the aim of using one function or the other function. You understand? You should be able to explain the flow of that particular course or your project to your stakeholders. For instance, now let's say you work as a remote or as a freelancer, right? And then they want you to help them to build a model. You understand it? Now they will ask you maybe for an interview, they will not ask you to write the code. In most interview, they will ask you to explain the process, right? To explain the flow, the architecture, or to explain how you will achieve the aim of that project, right? And everything revolves around you understanding all the understanding the reason why you use this function or that function. You understand what is the next step after this step. You guys now, for instance, let's say you cut your data set, right? You don't just jump to cleaning. You have to first inspect it. And I said inspection is just you getting to understand the data set, to understand what it entails, right? From there, you will now know what to clean, right? And then you plot your chart. And I said for charts, right? It is not that you are just putting charts for analysis. You plot chart to understand the pattern in that data set. Now, the class has been, the class has just been maybe, it's not or let me say, it's not straightforward for now, right? Because I'm trying to take it step by step. Do inspection, do cleaning, visualization, and then what? Data preprocessing, right? I think from on Saturday, we'll now start with full project straight up, so that for every data set we picked to work on, we are doing the importation, we are doing cleaning, we are doing inspection, cleaning, visualization, data preprocessing, and then we are now applying our models to it. So that is why before we move into the modeling part of it, I want to make sure, yes, that you guys fully understand the processes, right, involved in this, in this journey, in this journey of as a machine learning engineer. You must be able to communicate the architecture to your stakeholders. You understand? Now, what we are building is we are building a model, right, that can either do this or do that, right? For instance, now, let's say they give you a data set to predict, or let's say to predict if it will rain tomorrow or not. Now, if you are predicting rainfall, right? Okay, or they give you a data set now to predict maybe, or to build a model that can predict if a patient has malaria, right, or not. Now, these are two different projects, right? One is prediction, one is forecasting. You don't predict weather, you forecast weather. Understand? Now, for every project they give you, right, there's always a suitable model or a perfect model that can work perfectly on those what's it called now, on those projects. For instance, now, if you use a regression model, right, they picked or let me say they picked higher values. They consume higher values in your data sets, and then it makes them not to fully understand the data set, and that's why we have to scale it, right? So you must be able to understand the reason why we are using this model or that model. And the whole thing, right, it begins with you understanding the flow from the beginning. Okay, so this evening, I would start afresh, right? I will start afresh from the beginning of the course, which is to import the libraries up to the last class, and then kick off into label encoding. So I think that is that, right? I think we don't have any question again. Or do we? Please, hello, please, can you all hear me since? Can you hear me? Hello?
Yes, I can hear
Uh,
you.
I'm hearing you.
Yes. So we just hello, please,
I don't
let's
know.
be on. Hello, Olamiri.
Yes, sir. I don't know if you can just quickly. I was not in class the previous. That was on. Yes. So I don't know if you can just quickly give us a recap of what was done. Though I have the code already with me. I was able to get the code from Mr. Eze. So just want a quick recap so that I can work with it later.
Yes. I said I would. I'll just quickly do a quick recap from even the beginning, right, all through class and then to today's class too. Now, I want you to understand the process before we even begin to write the code itself. Now, it is data collection, right? Data inspection, data cleaning, data manipulation, right? Visualization, data preprocessing, and then you begin to do your training and your testing. Okay. So please give me just 2 minutes while I launch my Anaconda, and also you guys can launch yours as well too. And then we'll just kick off. Okay. Yes. So Favor, Uchoma, right? Please, I'll be what's it called now? Also working through that outlier part as well too. So just just take note of it when you.
Okay, sir.
All right, thank you. So please let's launch our Anaconda. Minutes. Hello, please. Hello. Hello. Please.
Hello, sir.
See my screen.
Yes, sir. I can
Yes.
see us.
Are we here?
I am here.
Wanted to know whether it's in the network.
Okay, sir. Hello, Mr. Sam, are you with us? Last I go off my laptop. I don't have much battery. Okay.
Okay. Hello. Hello.
Hello,
Hello.
sir. You're
Yes, sir.
welcome.
I was in a call. Okay. So as I was saying, right, this evening we first start with how to download data sets from Cargo. Okay. So let's say this Cargo here. Cargo. Then you have to sign in. Sign in with your mail. Okay. So let's look for one data set here. Data set here. Let's look for classification. Let's say you want to work on let's get something on health. Let's see this bank chunk, right? Okay, okay. Then download. So I think I'll send this data set to the group chat on WhatsApp so that we can all have it. Okay. Okay. Now let's now start with our code, right? Please. Okay. So I'm gonna close my. Yeah. Okay. So let's say I'm looking at sending this data set to group chat. Okay. Sorry, let me see my name. Sorry, I'm coming. So I'm saying this finance was right away. We'll give you some seconds. Let me just send it to group chat on WhatsApp. Okay, so we can get from the group chat now on WhatsApp. Hello.
Sir. Okay, I thought you are pushing it via email.
No, through WhatsApp now. Just check your WhatsApp. It should have dropped. I'm still loading. So please, let's proceed. Why it loads up? Just go. Okay. So now the first is what? First import the libraries, right? So we are importing pandas. Import pandas as PD. We import Cbon as SNS. Import matplotlib dot pyplot as PLT, right? We import what's it called now? So this is from sklearn. From sklearn dot preprocessing import label encoder. Then from sklearn dot preprocessing import min max scalar, right? Hello.
Yeah, we are with you.
All right. Min max scalar. So it's still loading up. Still loading. Okay. Now let's now import or to load the file. That will be df. Let me load my screen. Equal to pd dot read underscore csv. Then you paste what? You paste the file path. Okay. Copy as part. Come here. You have it here. Okay. Now there are two ways to this. You can either add a double slash here, right? Double slash here, double slash all true, or you leave it as a single slash, then you add your R, you add R here to read. Just copy message. This I can't send a file here now on this thing. On okay, let me check. Oh, sorry. Okay. Please, you can check the file now from this from the chat here. Hello. Hello. Hello.
Hello, we can hear you.
All right. Okay. So we have df.edge. Now, I said before things to what, just understand this file, right? What we're working on. Now, this file here, we call it a function. Now, it means that you want to build a model that will predict customers who are staying or who are leaving, right? Now, we have different columns there. We have customer ID, we have names, credit score, geography, gender, age, till what we call existed. Now, this last part here, this last part here, existed here, right, is our outcome, is our target variable, right? Now, the next step is to look at, is there any columns, right, which are not needed, which are noise from here? Now, we have customer ID, we have surname, and then that is all. We have customer ID,
Sorry, sir.
and then
Sorry, sir. Can you come again, sir? You said, is there any column? I didn't hear you from that part.
I said, is there any columns, right, which are not needed here, which are not useful for the modeling? You get now? Now, your customer ID, your surname, they are noise. They are noise in the sense that they are not needed for your analysis or for the modeling. You understand? So we have to drop out the customer ID and then drop the surname, right? So we need our credit score, we need geography, we need gender, the age, the tenor, the balance, all okay, let's say we need all of that here, right? Now, this last column here, existed, is our outcome, right? Is our outcome. Now it means that we are predicting if a customer will stay or will leave. You understand? Okay. Now let's now start to inspect the data set. Let's do df.shape, right? Now here now shows that what we have 10,000 rows and then 13 columns. Good. Let's do df.isNull. Dot sum. Okay. Now this all true here, right, shows that there's no missing value in any columns here. Good. Now let's now drop the noise. So let's drop the noise, or let me say, that's noise. So that will be df dot drop, right? Then have a list bracket. Then we list what? Customer ID in a quote sign. Don't forget customer ID, comma, then surname. Okay. Now, last class I said, if you are working on the column name, right, you have to what? Specify that will be axis equals to what? Equals to 1. Then in place equals to true. Now, this in place here, it means that you are approving that, yes, that you want to remove the customer ID and surname totally from the data set. Okay, then you run this now, right? And then you can now check df.edge to cross check it. You see that yes, we now have credit score all up till our existed. We have removed customer ID and also removed the surname from the columns. Okay, good. Now let's now plot in some charts. Let's plot what we call balance, and then let's see our salary too, right? So we can say now The reason why I'm plotting balance and salary is to check if that two column, right, has an outlier. Okay, that is, I'll be using a box plot to plot it. That was why I imported, Cbond and then matplotlib. Okay, so that will be what plt dot figure. Please, I'm very fast, right? Because I want to, just rush through the previous classes as a revision. Okay, so plt dot figure, we have our fixed size, what's equal to, let's say 5 by 5, 5 by 5. Then SNS dot box plots. Then we have what? We have our df, comma, so df equal to equal to, let's see, what's it called now? Let's plot balance, right? Balance. Okay. Then plt dot show. Okay, good. Now these columns here, right, does not, sorry, this column called balance does not have an outlier. Now, assuming we have dot outside these are box plots here. Now, that means we have to remove the outlier using the IQR method. Okay. Now let's also plot what's it called now? Salary, the salary too. Let's see salary. That will be plt dot figure. Our fixed size equal to 5 by 5. SNS dot box plot df comma x equal to this, right? Then plt dot show. Okay, good. Now it means that this file, right, does not have an outlier. Okay, very well. Okay. Now, a question. Please, do you have any question from the beginning to where I stop now? Please, question. Hello, question, please. I'll call names now. Mr. Sivinos, you have question? Hello, Mr. Sivinos, you have question? Okay, Alice, no. Mr.
Any class task. So far, I didn't really understand the first chat. That's just I was struggling with my phone when you did that.
Okay.
Mm.
Thank you. Yeah. Wait again. Favor Olamo, are you here today? Favor, that question. Hello. I can't hear you. You're speaking now.
Can you hear me?
Yes. Please, that question.
No. From beginning of where it starts to where you stop, I don't have question.
God's will, do you have question? God's will. Mr. Nelson, do you have question? Ugochukwu, Olamiri, and Praise, please, do you have question? Can I proceed?
No question. You can proceed.
All right, thank you. Oh,
No question.
all right, sorry, I've been logged out. Network. Sorry, I'm not sure from locked on my system. Okay. Sorry, I'm showing my screen back. So, Mr. Sivinos, to your question, right? This is a box plot. And I said box plot is used to check or to detect for outliers in your data set. If you can recall, the previous class we had, we plot a box plot on loan amount and on I think applicant income. Yeah, I think so, right? If you observe the chart very well, what we see some dots, some dots outside this this tick here, this whisker. Now, this box plot here, it is called box and whisker plot, right? This is a box plot here. Then this tick here is called a whisker. Okay. Now, it's either you see some dots above this whisker here or below this box here, right? It means that that data set has some values which are either extremely higher or extremely lower, right? And that's why we have to do that IQR method, where you set your Q1, your Q3, your IQR, lower bound, upper bound, and then you mask, you mask out the applier from the data set. Okay. Now we plot this box plot here on the two columns, which are salary and then what again, and balance, and then we find that we don't have any outlier on it, right? Let's say df.ed. Okay. Now, if you observe very well, right, we have credit score, we have this our age here as number, we have tenor, we have balance, we have number of products, as card is active, salary, and then existed here. Now, okay, go on, Gochuku, your question. Raise your hand.
Sir, it's favor. It's not good.
Favor.
Okay, sir. If this data set is given to me now, let's say you did not work on it and you gave it to us, how do I know the one that I'm supposed to look for the outlier? Like now you used balance and estimated salary. If I'm giving
Okay.
this work, how do I identify the one that I will use to find out if it has outlier? That's where I'm having that difficulty.
Yes.
That's at detecting
Yes.
outliers.
Yes. Thank you for your question. Right. I think the last class, I said it's not, or let me say, it's not in every data set you have an outlier. You understand? For instance, now, let's say you're working with, what's it called now? With, what's it called now? Maybe healthcare data set that has a BMI, that has a sugar level and all that there. Now, their values there is always in it, or let's say they follow the same pattern, right? It's either have 2.0, 2.5, just like we have it here as our credit score. You understand? Now, look at credit score here. But we have 619, we have 608, we have 502. Now, this all true, right? They follow the same trend, You understand? Now, most times, or look at this age here too, right? Age, they follow the same trend. You understand? Now, if you have, maybe you have columns like balance, income, price, and all that there, right? Salary, Now, there's high chance, right, that some values might be either extremely higher or extremely lower. You understand? Now, let's assume we have a column for salary. Abi? Salary. Now we have let's say the lowest person receive 10 naira as salary, right? Followed by let's say 1,000, right? Then was followed by 2,000. Then was followed by what? 1 million. You understand now? Now it means that this 10 here, and this 1 million here, they are extremely higher and also what? Extremely lower. You get now? Now if you now plot this salary here, on a box plot, there's high chance that it might have a dot, right? A dot here. That is for the 1 million here. It's extremely higher. You can't compare. See the gap between 2,000 to what? To 10 to 1 million. Do you get now? Yes, but assuming it's maybe columns like gender, maybe 1 and 0, or age, or credit score, Now those columns there, they follow the same pattern or same trend. You understand? Yes. So there is a little chance of having outlier in that column. But columns like balance, price, salary, maybe income, profit, and all that there. Those columns, there's high chance that it might have an outlier. Now, to be on the safe side, you just have to confirm it. You understand? Normally, I'm supposed to plot it, to plot a credit score, to plot age, tenor, one after the other. But seeing this now and seeing this here, right, I can just, what's the word now? Just conclude that, yes, that there's no outlier in credit score, no outlier in age, in tenor, in others, right? That's why I just went straight to plot the balance and the salary. So most times now, just look for anything monetary, either balance, profit, salary, income, right? As the case may be. Now, in those columns that you target to plot the box plot on to check for outlier. Please, is that clear? Favor.
Yes, sir. Yes, sir. Thank you.
All right. Now, this is where we now start from the last class, right? Now, if you observe closely here too, we have these columns there, balance, right? And salary here too, right? Now, the numbers here, they are very high, like very, very high. Now, let's say, for instance, now, I check for the minimum of credit score, the minimum of age, the minimum of tenor, of balance, of a number of products, up to this our salary here, right? The minimum of each is nothing compared to the minimum of what of this our salary here. You get now? So let's say we do TF dot describe, right? Now see the mean. Okay, good. See the mean. So see the minimum of what of credit score is what I be 350. The mean of age is 18. The mean of tenor is 0. The mean of balance is 0, Abi. Up to what? Up to we have 1, 0, 0, 11, 0 here. Now, we believe that we have some models, some algorithms that focus more on the higher values. You understand? And I said the beauty of analytics, right, or machine learning, or let's say the main factor that determines your analysis are your minimum, your maximum, your mean, and your standard deviation. Now, those features, or let me say, those functions, right? They contribute majorly to your analysis. You understand? And also to your modeling too, when it comes to machine learning, right? The standard deviation, your mean, your maximum, and your average. Now, that is why every model, right, working on is targeting the mean, the max, the standard deviation, and then the STD. You understand? Now, looking at this mean here, we have here, right, all through here, we can confirm that the highest value is what? Is credit score with the mean of 350. Now, it means that this 350 here will dominate all others we have here, right? Now, to avoid that, we now have to scale the data set. Okay. Now, also to looking at the maximum here too, the max here, we have 850 for credit score, we have 92 for age, we have 10 for tenor, we have this value for balance, right? And then this value too will be for salary. Now, it means that salary and then balance here, we dominate the ones, we dominate all these values we have here, right? And then it makes your model not to be accurate. Okay. Now, to avoid that, that's why we now have to scale. Yes, we must scale the data set. Okay. Now, for scaling, I said we have two methods for scaling. We have the min-max scaler and then the standard scaler. Now, for min-max scaler, right, we are focusing on the minimum and the maximum. Now, it means that after, right, after we have applied what? Applied, what's it called now? Applied the formula or the function min-max scaler to this table here, the mean here, right, will be 0 or true. Now, it means that for credit score, it will be 0, for age, 0, tenor, 0, all through the columns, right? And then for maximum, right, it will be 1 or true. Sorry, someone took a chat here. Let me just take the chat. Oh, what's very low? Sorry. So let me use the very yeah. Hello? Is it loud now? Hello, Osivinos. Is it okay now? Hello.
When the other
Sha,
lady was speaking, her voice was very clear, but your own is deep inside, not that sharp, sharp.
Now, is it clear now? Okay.
Because it's
Okay.
raining here, I can hardly hear you clearly.
Oh, sorry about that. Okay, so as I was saying, right, I said we have to scale the data set, and then the main reason of doing that is just to have a model that is perfect and accurate. You understand? Yeah. So we are scaling the minimum, we are scaling the maximum using the min-max scaler. Now, I said we have two functions, right? We have min-max scaler and we have what? Standard scaler, right? Now, you don't use two of the models, so two functions in one project. It's very wrong. You either use one of it in a project. Okay. Now, that is one. So someone will be chat again. Let me check. This is the earpiece. I'm using the earpiece. Is it clear now? Hello? Hello? Favor? Hello? Hello?
I think
Hello?
she's talking to Mr. Silvanus because he said his
Hello?
mic is open.
Favor
Hello?
is talking to Sylvanus.
Okay. All right, thank you. Thank you.
Okay.
Yes. So yeah, as I was saying, right, I said we have to scale. We are scaling. See, the whole essence is that we are trying to give or to have a model that is accurate. Okay. Now let's even check this our outcome here. Now, right, it is very important that in plotting your chart, you plot a count plot to know the distribution of your target variable. Okay, so let's see what we have right in that existed. Let's see plt dot figure our fixed size equal to 5. We have sns dot count plot. We have df comma x equal to this. existed, then SNS dot PLT dot show rather. Okay, now wow, look at this column here now, right? We have 0 like up to 7,000, and we have 1, right, up to what? Up to 2,000. Now we have 0 here, we have 1 here, right? By default, what should have been here is what? Is yes or no, right? Yes or no. Now it means that this column existed. This column is active member, has credit card, number of products here. Now these 3 columns, sorry, this 1, 2, 3, 4, this 4 column has been encoded, right? As what has been encoded. Now the question is, how do you know which is yes, right? And then which is what? Which is no. Now, for every encoding, we use what we call label encoder. Label encoder, right? Sorry, encoder, or what? One hot encoding. Hello. Hello, please, can you hear me?
I hear you. I can hear you.
Can hear you.
All right, thank you.
You're just
Yeah.
inside. I can hear you.
Now, for every encoding, right, we have what we call for every encoded variable, right, we use either label encoder or we use a one hot encoding. Now the question is, how do you determine what is 0, right, and then what is 1, Abi? Now in this case here now, right, I said the right or the initial values in that column is yes and no, right? But here now, what we are seeing it as 0 and 1. Now for label encoding, right, the way it works is that it starts with as or let me say it assign 0, 1, 2, 3 up to infinity based on their alphabetical order. Now it means that since we have yes Abi and then no Abi, right, and n, right, n Abi, n is no, n come before y, so it will assign no as what? As 0, right? Then assign what? Assign yes as 1. Okay, this is how it works. Assuming it is not existed, it is maybe we have it as gender and gender, right? Now for gender, we have male, we have female, right? Now F, right? Then we've assigned M as 1. This is how encoding work. Okay. Now with F2, we are also going to what? To encode this geography, gender. So just these two, geography and gender. Okay. Now, yes, I plotted this chart here to check for data balancing, right? Now we have what? We have more no, right, than yes. Now it means that if you train a model with this data set here, and that model will be predicting every what's it called now? Every new input as no, right? Because you used a data set that is not balanced. Okay. Now this is the reason why you have to inspect what you are doing. Right now, there's a technique that will not help us to balance these columns here, so that the yes and the no will be on this. We have the same value, just to avoid having a model which is not accurate. Okay. Let's just continue with what we are doing here. Okay. Now, let's say, okay, let's let's now move back to what? Let's now move to now before we do that this thing, before we do the scaling, right? Let's first encode this geography and gender to numbers to numbers using a label encoder. Okay. I've already bringing the library here as this here, right? Now I said what I have here is just a library. All right, a library. You now have to call it up as a function. So that will be label encoder, right, as a function. Then you cannot save this as what? As a variable called label. Label equal to what? Label encoder. Okay. Let me give a note here. Let's say I called the label encoder library, right, as a function, and then save it as a variable called label. Okay. Now note that what this guy does here is what? Is to transform every text to column. Now the question is, why do we transform text to column? Let's talk. Okay. Hello, please. Hello.
I hear you.
Yeah.
All right. Now the question is, why do we transform text abi to column? Now, the way it is or the way those models works. Now, those models, they are numerical models. They understand number. In fact, the way our brain works, right? Our brain understands binary, not text. You understand? Now, those models, right? They understand number. You get? They can't process text, right? Now, it means that we have to what? We have to use a function that can transform the text we have to numbers. Now, it's just like maybe we have somebody from Hausa and then somebody from Igbo, right? Now, before they can communicate very well, right? It means that it must be what? An interpreter that understands both language. So that's exactly what this guy here, label encoder, is doing here. Now, it's helping us to transform the text column we have to numericals, to numbers, so that model cannot process the data set without having any error. So it is a must that if you have any data set that has text as a variable in that data set, you must what? You must encode it. You must encode it. Okay. Now, we have two columns here. We have geography, right? We have gender. Okay. Yes, we have what? Geography and gender. Now, let's now save that two columns as a variable called text code. So say text code, right? But equal to df double list brackets. Then we have geography. And then what? We have gender. Okay. Now, let me come again. Let me.
I have a question, sir.
All right, please go ahead.
Okay, so you said any text column, like in our data set, if we have a text column, that we can be able to convert it to numerical column. So I'm asking now, what if the text is a name, let's say name, or okay, not really a name. I don't want to use name because we can actually see that a name might not be useful for the data set. But let's assume that it's maybe a shopping. The data set is dealing with shopping stuff like that, and then we're having things like biscuits, spag, and all these different items. Do we have to encode that?
Yes. Yes. You must encode. Please,
Okay.
favor, please hold on, please. Now, favor, please hold on. Now, right, you must encode. Understand? Now we have two ways of encoding, right? Now, let's now assume that that you are trying to predict customers' review. You understand? Right? Now, you know that review now is not a single word, right? You know here now, here we have Spain, we have France, we have Germany, Nigeria. Right now, these are single words in a column. You get now? Now imagine we now have a review like, I love this product. Oh, this product is very good. Eh? Now in that case, we now have a different method to transform it. We don't use label encoder, and then we don't assign them with zeros and one. We now have to vectorize that column. You get now? But for single word like country, Nigeria, male, female, yes or no, right? You do label encoder to transform them to zeros, one, two, or three, as the case may be. But for text column, maybe probably like review, review, what's it called, review, sentiment analysis, and all that there. You have to vectorize it. So probably when we get there, I'll show you how you can vectorize data sets, right? Not encoding it. Maybe please, that clear?
Yes, sir. Thank you, sir.
All right. Yeah, favor, please go ahead. The question, favor.
Good evening, sir. I just want to be sure for what you said. You said that when it's being encoded, it uses the alphabetical letter. So meaning that if you want to encode France, it will use the first letter F to encode it.
Yes. Let's say now, let's say we have France, we have France, we have French. You get now, Now, we have FR here, and here we have FRE, right? Now, to do what? To assign this guy here, this France as 0, and then what? The French as 1, right? Because this this FF here, the same thing. RR here, the same thing. Then A comes before E. People, exactly now.
Yes.
All right, thank you. Okay. Now, let's now. So here, right? At this code here, I only selected the two columns which are text, which are geography and gender from the table, right? And then I save it as our text code as a variable. Okay. So here now, let's now apply this our function. Okay. Now, if you observe something, if you observe that the values, right? They are looping down. At least, like they are listed. They are listed through the columns. You understand? Okay. Now it means that we want this function here, this function here, to also check through that column, right? So now it's more of you saying that, okay, this function called label encoder, look through this column called gender, and then anywhere you see text there, change that text to numbers, right? Now, since the model since the function label encoder, right, is looking, is taken down, then we now have to use a for loop. That will be for coal in text school, then DF cool equal to label dot fit underscore transform, then DF list cool. That's all. Okay. Now if I come in now and say DF dot edge, right, to check through, you see that what it has converted the geography and gender to numbers. Now let me just explain this line 13, 14, and 15 again. Now, I said what we are doing is this, right? We are working on data preprocessing. We want a model that can learn, that can understand the pattern, right, we have in a data set. And then we want the model at the same time to not have an error. That is one. And two, to be able to give us a perfect and an accurate a prediction or results, right? Now, coming through that the whole process, we find that we have two columns that are text or that objects, which are geography and gender, right? And I said these models here, they only understand numbers. And I said it's just like you have somebody who speaks Igbo, right? And then somebody that understand only Hausa. Now it means that the two of them, right, but they can't communicate, Abi. Yes, until we have a person that understand both languages. So in this case here too, the model cannot process text, right? And we have text in the data set. So it means that we now have one middleman, an intermediary that can help us to convert that text we have to number so that the model can process it. And that's why we now have to import the library called label encoder. Now it's up there, right? Up here, right? As a library. This is a library here. This is a library here. This is a library here. Right? The library here. Now here is just here as a library. It's not working. So we now have to make it work a bit by bringing it in as a function. Now, what makes a function is when we had this curve bracket here. So with this now, right, what becomes a function. Then we now say this function as a variable called label. Okay. Then moving forward now, we now look at, okay, let's see the columns which are text from our DF. And then what we see that it's only the geography and gender. Now we now selected the two columns, geography and gender, right? And then we save it as text code. Now, the reason why I did this double list brackets is because these two here, they are data frame, right? And then it's more than one column, right? Then coming down here now, this for call in text code. Okay, I said, you know that we have the values inside each of these columns here, dropping down like a list, right? Now, the way the function works is that we are saying that this function check through these whole columns here from the 1 to the end, check through it, and then anywhere you see text, transform it to number. Now this code, this function here, it means for call, that is for column in text code, right? Any role in that text code, in that text column. Now, knowing that our text code is geography and gender, then df code equal to label.fit underscore transform. Now this function, right? This label fit transform is just like okay, just like you want to dye your clothes, right? Now you have your dye, and then you have your clothes. Now see the label, this encoder here, as our dye. That is what will help us to transform that text now to numbers. Now we are fitting this text code, right? Just the way what you fit your cloth inside the dye, right? You fit it, and then the process of changing the pattern on your clothes, right? What it's called, it's called a transformation. So here itself too, you are saying fit the data set, which is df code, right? Df code here, and then transform it to numbers. So in this point here, or I'm gonna say at this point here, the function is transforming everywhere that it found that, okay, this is a text here. You see that text to number using this label encoder here. Okay, and then I came here to confirm, right? To confirm maybe it has truly transformed the text to numbers. So right now we have it as 0202. Now let's say, for instance, now I check my, let's say I do df this bracket, this, right, dot unique. See, but we have 021. Now 021 abi. Let's see. Now we have what? We have France, we have Spain. I think we have, let me check the data sets. I did not do that at the beginning. Okay. Let me check data sets. I'm coming. I'm coming now. Okay. We have France, Spain, and Germany. Okay. So back to the code. Right. What we have France, Spain, and Germany. So what we have France, right? France, we have Spain, and what we have we have Germany. Okay. Now F here, F is what? Is at 0, right? You see, we have F here, France, right? At the first word now, you see, as is 0 here. Then we have G. G will be what? G will be 1. This will be what? This will be 0. Equal to 0. Then this what? This will be equals to 2. You see, so you have 0, 1, 2. Okay, and that's why we're having it here as numbers, not as text. So at this point here, right, the model or the function encoder has helped us to transform the text from geography and genders into numbers. Please, any question before I move further? Any question? Any question, please? Any question?
Sorry, sir. This under this geography.
Hello.
The
okay.
The array 0, 2, and 1. I don't know if you can scroll up. I want to see that under this geography. It's showing number here, like that. Is it France or something?
We have France, Spain,
okay,
and Germany there.
Okay, yes. So that numbers is also based on the alphabet. Is it also based on the alphabet?
Yes, and Germany, right? So this is 0, F now, F, G 1, and the S 2.
So what if there is another this is starting from letter G? Let's say GA. maybe GA something.
Or GH now, Ghana now, right? So
Yeah, G.
this will be 1, 1, 2, 3. Sorry, 0, right? This will be 0, 0. This will be equals to 1, right? This will be what? Equals to 2, and then here will be 3. So we now have 0, 1, 2, 3, stuff like that.
Okay. Thank you, sir.
Yes, yes. Okay. Please, your question. The question. I think I'll call names now. I'll start from the down. Praise, any question? Favor, any question? Ugochukwu, any question? Mr. Nelson, any question? Hello?
No question. No, not
Hello,
really a question.
hello,
But why?
sir. I have a little question.
All right.
This DF column, DF co, is there any other place it has been given instruction on how to perform? Because I noticed before anyone is called up, they are assigned something. But in this one, I saw the test code was the one giving that test code is equals to DF geography gender. So I was wondering, I was expecting to see the test code in the label feed transform test code, DF test code. I was seeing code. So I was wondering, where is he getting his, is it a normal variable? Or, I don't know if you understand what I mean.
Yes, yes, yes. I understand you very well. Yes, and then thank you for your observation. Now, right, at this point here, we assign this text here as text code. Now, this is a for loop. This is a for loop. For loop. We call it for loop in programming. Call it for loop. For loop. For loop. Now, for loop, it has its own variable. Its own variable by default. Right? Now, I'm saying for call in text code, right? That is for column in text code. Now, by default now, I have transformed or not transformed now. I have transferred this my text code as column here. You guys now?
Yes.
Now it means that this code now represents our text code. So let's say I have here as column, right? Columns now, right? Now it means that here too will be column, here will be column. You get now?
Okay.
So yes, we have transferred this variable here, text code, as code. That is why this text code only appear in the for loop in this upper part here, right?
Okay.
And then the new variable now takes over, or it now override the text code itself.
Okay. So, but
yes,
in another word, can something like for Tesco, DF Tesco, label feed transform DF Tesco work?
Come again.
Can something like instead of
no.
It can't.
Now it should not be for Tesco in Tesco. You guys now.
Okay.
Right, for test school in tech school.
Okay.
Then DF school like that would work.
Okay.
Yes, thank you for that.
All right.
Okay.
So I have a question, sir.
Yes, more please. Your question.
This call that you're talking about, is it converting it, okay, the column, is it the entire column at once, or it's converting each cell in the column? Like it's iterating through each cell?
Yes. Let's follow up now.
Okay.
Is
it each column or each cell in a column?
Each cell in that column, gender and column geography, not the ODF now.
Okay.
Right. Now you know that we only selected geography and gender from the ODF itself. You get now?
Yes, sir.
Hello? Hello?
Yes, sir.
Yes.
I can hear you.
Yes, so now the focus now is now only on geography and gender, not
And
the ODF. Yes. So
no,
okay. All right.
like I mean, the entire column for geography, is it going to transform? Because I don't know how to put this in English. Like line 14, text call equal to DF, then that square bracket again. That geography now, is it?
The entire geography, yes.
Can we
See,
keep
okay, now
geography as 0 and gender as 1, so that in line 15 where they put for call, then the following line DF at index 0, that will just take care of the entire geography column at once, and then at index 1 maybe for that gender column at once? Or is it going to be that for the geography now it will just check for the first country, it will convert it, second country convert, like each of the countries, or it will just convert the entire column, that's
at once,
geography column
at once, yes.
then at once?
At once. Yes, yes.
Okay.
At once. Yes. You know now, this part here, you get now, it's just like just like you have let me say you have baskets now with different balls, right? They now pick all the green balls in another basket, and you now pour ink there. You get now. Now that ink will transform the colors a bit at once now. You get now.
Yes, sir.
Yes. So here's F2, the same thing too. The function is transforming all the text column to numerical at once. Not you know, not taking the first one, second one, or the third one.
Okay.
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 Okay. So let's proceed now. Let's now move towards our scaling now. Back to our scaling. Okay. Yeah, let's see. Now, for scaling too, the same thing too, right? We are scaling this our DF here, this old DF here, because we now have everything now in numbers now. Okay. That will now be min max equal to min max scalar. So is it like okay? Yeah, min max scalar. Now we have called that library, import min max scalar as a function here, function min max, and then we save it as what? Min max as a variable, right? Okay, they run this now. So we can say df scale. Now this df scale now is now a different variable, or let me say df2 rather. df2 what equal to min max, our variable for scaling, dot fit underscore transform. Then have what? df. That's all. So if you now print out this our df2 here, right, what we see it being transformed over there. So this is our new table now. This is our new table. Okay. Now, what we did here is that we have applied this function min max scalar formula. Now, this min max scalar, it has a function, so it has a formula, right? It is x minus x min all over x max minus x min. Now, we have applied this formula to what? To our data set here. That is the min max scalar. Then we fit it and then we transform it. Now, this is a scaled data set, right? Now, after the function has transformed this old df here, right, after it has scaled the DF, right? Then it now return it in a number array or numpy array. It's not numbers now. Now you can't come and say df2 dot edge to give you error, because it has transformed it to a numpy to numbers array. Okay. Now remember I said what's it called now? I said once you applied this function minimal scalar, right, to your DF, it will scale it, and then you have all the minimum as a 0, right, and then the maximum as 1. Now let's try to convert it back let's try to convert this our scaled df2, right, to numbers, sorry, to pandas, and let's see if it will work. Let's say df2, df2 equal to pd dot to underscore data frame. I'm coming columns of is equal to is equal to this now. Sorry, I'm trying to do something. I'm trying to see if you can convert it back to this thing, to data frame. Okay, let's see. It has error. Sorry, putting the code. Okay. Yes. So I think we have can I have our df2 now? df2 will work. df2 dot edge. Okay. I'm coming. There will be df2 comma this. So let me run off it again. Let's see. Okay. You see now? Now that we have now what I did here, right? What I did here is to convert this our df2 we have here, this scaled result here, right, back to data frame. data frame as in df with pandas. You understand? Yes. So I did df dot data frame. Then I have the code as a df2, comma equals to columns. Then I listed all the columns there. Then how it is. Now, what we'll have here, right? This is 0.58, 0.538, 0.516, 0.0, 0. Now, what we have here, and what we have in our df dot edge, right? Now, these two tables here, they're the same thing. Just that this one here is the original, the original values on the table, right? While this one we have here is our scaled df. So if I come here and say, okay, let's see df2 dot describe, right? Describe. Now I said after you scale it, the minimum will be 0, the maximum will be 1. So let's confirm it now. Now see the mean. Now see the mean. 0, 0, 0, 0, 0, 0, 0, 0, or true. The maximum 1, 1, 1, 1, 1, 1, 1, 1, or true. Right? Now see the way it was initially. df dot describe. Then we have Isabi. We have mean of 350, 0, 18, 1. Now I said this 350 here, right, will dominate all other values we have here, and also this value here, this 25, and then this one too, right, will dominate all these other values here. Now to avoid that, we now scale it, and for scaling, I said if we applied min-max scaler, now it means that what? It means that we are converting it or scaling it to have the same units for minimum and for what? For maximum. That's why we have to what? Have to import this the library. I call it here as a function. I fit and transform it, and we have this result here. Now, this result we have here, right, is the scaled, the scaled values for each columns on the table, right? Now, to confirm it, see, for your project or for the project, this code here, this code 49 here is not needed, but just to show us that yes, that this function actually works. That's why I went ahead to convert it back to a data frame, right? And then we can now view it as a table, having the scaled, the scaled result. Now, this 0.53 and 619 here, they are the same value. This is scaled. This is just the actual value. They're the same value. Then to now show us that yes, it has actually scaled it. Then I print the describe to see that yes, that we now have please favor, please hold on, please favor. Now, but we now have mean of zeros or true, and then max of 1 or true. Please go on, favor. Now go on. Hello, favor, speak now.
Can you descale a scaled? Once you scale it, can you descale it back to the original form?
I can't hear you.
Once you scale it, when we want to clean the data, we have to scale the data, which is what you did now, the df2. Can you descale it back to the original form, like turn it back to the original form? There's a way to reverse the process.
You can't do that. You can't do that. Because there's no point now. There's no point doing that now. You get now. So that is why we now have to assign a different variable for it. Can you hear me? Hello.
Yes, sir. Yes, sir. I can hear you.
Now that's why I assigned a different variable, which is df and df2, right? The scaled one, and then the original DF. You understand? Now, the reason why you scale there is just to have just to just for you to have a good result for your model. Do you understand? Yes, and I said that it's not. I think last class I said it's not in every data set you scale. You let scale when you have a what's it called now, a column that has higher values. You understand? Dealing with data set from medical, you don't scale it. You don't scale it because in fact, because almost all the columns, we have the same trend, the same the same numbers. So you don't scale that kind of data set. But when you have something like price, salary that has higher values compared to others, then you scale it. So, and I said even this function, even this code I wrote here in line 49 here, I just did this right to show us that yes, it has it has scaled the mean to zeros and the max to 1. Now for your project, for your project you are doing, there's no point, right, doing all these steps here. It's just from here. These are DF scale. It's what we feed to the model. Is that clear now, Favor?
Thank you, sir. Yes.
Yes. So please, any question?
Yes,
Someone
sir.
do it. Okay.
Yes, sir.
Yeah, go on, please.
Okay. So that means that anytime we apply that min max on a data set, it automatically becomes a number array, and then we
Yes,
can
number
now
array.
yes, a number array like from line 48.
Yes.
Okay. So we have to convert it back to data frame.
No. I said it's not. In fact, for your project you're working on, there's no need to convert to what's called now, to send it back to data frame. Just leave it the way it is. I've logged that.
Okay,
Yes.
that means line 49 is not like this line 49, I can take it away. There's no need.
Yes. There's no need. So you let feed the model with the scaled GF2. Is that clear now?
Okay.
Yes.
Yes, sir.
So yeah, but then I only did this to just explain further that yes, so that minimum scalar, right, actually what scaled it, and then we now have minimum of zeros and then maximum of 1.
Okay.
All right. Yes. So please let's stop here. Then I think the next class now, right? Next class now, we now move into our training, texting, and splitting, and probably into fitting the model to our data set. Okay. So please, any question?
For now, no question.
Okay.
I think Grace typed the question.
Yes. He said what? He said, what if there's a need, right, to go back to correct an error before scaling? Okay. Yeah. Let's say, for instance, right, you want to correct, let me connect right now. I'm coming. Let me get one error I want to correct now. Okay. Let's say, for instance, you want to, I'm coming on. I'm coming. I'm trying to get to get an error you can correct. Okay. Let's say for instance now, right, we want to drop age. Yeah. I think you are stupid chatting. Okay.
Yeah.
Now let's say we want to drop age. Age now, and then we have skilled, right? Now can come here and still okay. Uh, once you have skilled, right, you can't drop the age again. You understand? Yes, because it's now in non-pi array, right? That's why most times you can always come to your maybe here, right here, and then, or let me say above here. Let me use here for instance. Let me say here now, right? And then you create what? You create a space like a new cell here. You can just click on it. Make sure it's on the blueprint. Then press B, what is below. Then now come here and say, okay, df dot what dot drop, right? And then what we drop our age, age, okay, age, comma index, sorry, index axis equals to 1, right? In place equals to what? To true. Now, if all this code here now, it will work, Abby. Yes, but then you can just come here and then run also. They still work too. That means I'll have to here will give me error now. Then come here and remove age from here. Since I've dropped the age, then run it. Right, it still works too. Okay. So there's always you can always run your code all over again. Yeah, even network. Sorry, I'm logged out on my system. Okay. Okay. I think I'm back now. Okay. So I said you can always you can always scroll through and then add new what's it called now? You had new what's it called now? You had new cell, and then you impute your function based on your collection, and you run all cells. Yeah. Even if you use VS Code to write to, right? If you use VS Code to what's it called now? To run your code, you won't be seeing the results as it is like this after one, after one code or one function, right? You see the output here. Now on VS Code, you write your code all through, you run it. If you have any error, you now have to check through again and see where that error comes from, and then you fix the error. So you can always insert a new cell above, and then you input your error, then click on cell and then run or cell. Press. Hello, press. Hello, press. Hello, press. Is that good now? Please, can you hear me? Hello, can you hear me? Hello.
Yes, I can hear you.
I'm not here at all. Hello. Hello. Hello.
I can hear you. I can hear you.
What's going on? Oh, sorry. Sorry, I was logged out. Okay. Sorry. Hello. 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 Please. Hello. Can you hear
Hello,
me?
sir. Yes,
All right,
sir.
thank you. Yes. Yeah. So I said if you have any error, right, to update, you can always insert a new cell above it. You put in your code, and then you run all. You run all. All right. Next question, please. Favor, the question
Sir,
again. Okay. Go on, please. You speak. Go on.
mine is not. It's not really a question, sir.
All right.
I don't know if you can just. You said you were talking about the steps for working with data. I
Okay.
don't know if you can just sorry, I opened documents now. You said data collection, data inspection, data cleaning. I only have data visualization after that, just four. I don't know if you can just help me repeat so that I can.
Okay. I said data inspection, right? So data collection, data inspection, data cleaning, then your EDA, right, which is a data visualization, or you call it exploratory data analysis.
Call it
Then
what?
data exploratory,
Exploratory.
yes, data analysis. Then we have data preprocessing, right? Then we have okay. Now inside that data visualization, we now have three. We have what we call a feature engineering, right? Feature
Inside
scaling.
data processing.
Yes. We have
Okay, we have
feature engineering, feature.
okay.
Feature, that's
F
FEAT. You have
R
FE, yes. No, not
okay.
future, not few. FE, features now, like
FEAE.
variables. Yes,
Okay.
FE. Yes, we have
Okay.
feature engineering, right?
Okay.
We have feature scaling, feature transformation, and feature selection, right? Now, today we have done feature transformation using label encoder, right? And then we scale with our feature scaling using min-max scaler. Is that clear now?
Yes, sir.
Let me type it here now. Let's say we have feature scaling, right? Which is what? Min-max scaler and standard scaler. Then we have feature selection. This we have a PCA, or let me say principal component analysis. These are PCA. Then we have K-best selection, right? And then we have a feature transformation, which is label encoder and one hot encoding. Is that clear now? Hello? Let's see here. Hello?
Yes, sir.
All right.
I'm copying.
Yes. So I will save this this note here on the Discord platforms and that platform, and then probably I'll give an assignment and work on it to submit it. Yeah. Then what's it called now? Then I think on Saturday, Saturday by 7 p.m. Right? We have another class. So please let's go the day. Mr. Sivinos, any question? Hello, this year. Hello, Mr. Sivinos.
Hello, sir. Can you hear me, sir?
Okay.
Hello, can you hear
Where
me?
is Godswin? I think he has job. Saying is falling aside. Okay. So please let's stop here for today. Right. Thank you.
Sorry, sir.
Hello.
Sir,
Okay. Go on, please.
okay. You said data processing, then you gave the items under it. Then I think there's
Yes.
also you said about training and some other.
Okay. Now, okay.
Yes.
We now have what we call it splitting, like okay, let's call it a training. Sorry, let's call it split. Sorry, training, testing, and splitting. Right?
Training.
Testing and splitting. Then we now have fitting the model. The next one, fitting the model. Then the upper, then we have evaluation of the model.
You said? Sorry, sir. What did you say?
We have fitting the model.
Yes.
Fitting. Yes.
Then the second
Then we
one, the
have
next one.
Then we have what's it called now? Model evaluation.
Okay.
Yes. So we should have some advanced ones too, right? Some advanced ones as well. We have what we call fine tuning. You know, probably you fine tune your model, you fine tune it, you do your research. You know, it's just a lot after this now.
Okay, thank you, sir.
All right, thank you. So good night, everyone.
Good night. Thank you.
Sorry.
Okay.